Brian Sappett. I'm the founder of SensrTrx. And a little bit about my background gives you some context around the product. I've worked in manufacturing technology for 18 years, and I own a company that did custom software for small and medium-sized manufacturers. We also did accounting, inventory, and production management systems for people. And the thing that I noticed over those 18 years was we'd spent all this time and money doing these, they're called ERP system implementations. And most manufacturers would still have the same 4 basic problems. Their inventory wasn't accurate, they couldn't schedule on time, they couldn't always deliver to their customers on time. They had quality issues that they couldn't really quantify. And then finally, we had inventory accuracy problems. And so I sold my other company and I created SensrTrx to help solve these issues. And almost every manufacturer asks themselves the same basic 3 questions. Everybody that I talk to. Are my machines running? And if they're not running, why not, right? It's like the simplest question you could possibly ask. And most people would say, well, in the manufacturing world, you have to have that, right? It's high technology. They spend hundreds of thousands of dollars on this equipment. And you would be right if you're Emerson or Monsanto or one of these huge manufacturers. But if you're a small to medium-sized company, one of the suppliers to Boeing or a supplier to an auto parts company, it's just not the case. The technology might be there, but you don't have the ability to use it. Then they go on and ask, well, are we producing to capacity? So if I can make 100 parts an hour and my shift is 8 hours long, I'm making 800 parts a day, right? That's another one that's not really easy to track. And then finally, what's the quality of our parts? So are we producing 1 bad one for every 100 good? Or is it 2, right? It doesn't seem like that big of a difference, but it's huge if you deliver short to your customer, right? You're not going to make them very happy. So the reason why none of this stuff exists for these manufacturers is that most of this equipment is not connected to any kind of network. I've heard numbers as low as 3% of the industrial equipment is connected to some sort of data acquisition network that comes from Cisco. And even if they had the data, they don't have the expertise to be able to analyze it or crunch it. And even if they had the expertise, they probably don't have time because they're cost constrained, time constrained, right? As all manufacturers are. And as I mentioned before, the current solutions, they're really complex and they're very expensive. They are built for Anheuser-Busch. They are not built for, a $30 million aerospace and defense company. And most companies resort to paper or Excel, right? And the solutions that are built for these small companies are built to look at a single machine, right? But they may have 40 of them. And there's no way that the production manager, the owner of the company, is going to walk around the shop floor every single day and look at 40 different pieces of equipment. It's not a good use of that person's time. So this is really why I created SensrTrx, to provide small to medium-sized companies with a solution that provides the right data at the right time for the right people, right? So if you're an operator of a piece of equipment, it will tell you how you are doing against your goals, right, on just that piece of equipment. If you're a supervisor over an entire department, it will tell you how your department is doing. And if you know that, you can improve it, right? What gets measured gets managed. I'm sure everybody's heard that one before. And over the long term, you need a system that can learn from the data. Most people in the tech space have heard of business intelligence software, right? Business intelligence software takes data from all over the place and puts it on a graph. It is dumb. It is not intelligent software. It only tells you what you tell it to tell you, right? What we really need is something that tells the user what the problem is and doesn't make him hunt for it, right? If I'm not producing to capacity, I got to dig through, well, okay, so the machine's not running as often as it should, and then why not? Oh, well, because Joe takes 4 more smoke breaks than the other guy on a different shift. You got to drill down into all of this information. But the data's there. The system should just go here. It's because it's down more often for a specific reason, and then you can go fix that, right? So maybe you get somebody to cover Joe because he smokes more than somebody else, right? And then the machine doesn't break down while he's outside. Pretty simple. Doesn't look too good. So SensrTrx is built on a single metric, and it's called overall equipment effectiveness. And it's a single number that you can use to represent how a certain piece of equipment is performing. And it's really made up of 3 different things. Availability, which we've talked about. Is the machine running when it's supposed to? And then from that, we can derive all kinds of different information that's interesting. So why is it down? Is it down more often on a certain shift than another one? Is it down more often with a certain operator, Joe, who likes to smoke, versus somebody else who doesn't? And we can let them understand how that's happening and they can fix it. The second one is quality. So are we producing good parts or bad parts? If they're bad, why are they bad? And each one of these is an individual metric that gets rolled up into that larger one. And then finally, performance. Are we producing to our capacity? Right? If we can make 1 part per minute, are we making 60 parts per hour, or are we making 50 or something like that? And we can figure out why. And everyone in the organization can use this software, as I mentioned before. It can be used by the operators to understand how their machine is performing. It can be used by department heads to understand how all of their machines are performing. And then obviously executives, whether it's an owner of the company or directors or vice presidents, they can make decisions on automation opportunities. Does it make sense to automate a certain line? Does it make sense to add another shift? Does it make sense to buy new equipment? And they can have real hard objective data to make those decisions. And then finally, the ERP users, the people that do the planning, that do the scheduling, that do the purchasing. If they have better data coming from the shop floor, they can make better decisions about what to purchase and when, right? So this is the overall architecture of our system. So we start with data collection. We can collect data directly from the machines automatically with no human intervention. We can also do manual data collection. So if you have a really old piece of equipment that we can't get on the network, they can hand enter it if they want. And then we aggregate that data and contextualize it. What I mean is it's not just raw information coming from a piece of equipment. We put it into buckets. What part was running? Who was running that one? Is there a different team running that shift? What shift is it? What piece of equipment is it? And we can put all of that information together so when you're looking at something that looks strange, you can find out why, right? And what else was going on at that time. And we summarize and calculate all of those metrics in real time and then produce dashboards based off of those. And those dashboards are role-based, right? So depending on who you are, you're going to get a different look. And I have a couple of examples here. So this is really an overview dashboard that we show people. And it shows this plant OEE number. This is sample data, right? Shows how the plant is performing overall. It shows how different machines are performing against their targets. You can see some of them are doing relatively well and some of them are not. And then some scrap analysis. So what are the percentage reasons of different types of scrap reason codes overall inside of the plant? But then we allow you to dive down and look at individual machines, individual facilities, individual departments, so that you can really see what's happening inside of your organization. And then you'll notice also at the top here, we have these little navigation cards where you can see how individual machines are performing. So if you have, maybe you're producing a new part on a piece of equipment, you want to monitor that, you can see how it's performing and it updates in near real time. So if there's a problem, you can go over and take a look at it if you're the department head or you're in maintenance or that's your machine. And then we allow you to drill down on all of these different graphs. So like this is downtime analysis for a couple of different machines, so you can see how downtime affects part production. And then finally, one of our biggest differentiators, because you're all probably this stuff probably exists already. If you Google some of it, you'll see it. One of our biggest differentiators is how fast we can get somebody up and running and how quickly they can get value out of the software. So we can typically get somebody up and running in less than a week. Most companies get values out of the product in 30 days, so they're getting real actionable insights out of the dashboards within 30 days. And I can teach anybody how to use the system in an hour. It's really easy. I show all the screenshots, right? It's really, really easy to understand. So that is one of our biggest value propositions, obviously, because a lot of the software out there takes months. And if you custom built it, it would take years to be able to figure these things out. And that's how it really fits in that small to medium-sized market. So, kind of where we are today, we have 2 customers live on the product. We collect, these are out of date by a couple weeks, we collect about 2 million data points a day, process and categorize that information. So it's a pretty hardened system at this point. Over 30 million parts have been tracked through the system. 86,000 minutes of downtime have been analyzed and 45,000 scrap parts. So we have a very, very high volume customer that's on the product that makes a few 100,000 parts a day, which is where a lot of it comes from. So then finally, how you can help. The biggest one, which I could repeat a couple times, is we're looking for more pilot customers. So people that are data-oriented, progressive, technologically oriented manufacturers that know that they could benefit from the data. So if anybody works in manufacturing, works in adjacent industries, or know anybody that would be interested, I'd love to talk to them. The other thing that we struggle with, which I'm sure a lot of you are thinking, is the connectivity problem, right? So there's a lot of old equipment out there that's not going to be replaced anytime soon. They have a lot of different protocols and weird stuff on them that we have to figure out. There's new products coming on the market all the time from a hardware perspective that help you do that. I would be interested if anybody has seen anything new that we could possibly use to connect to some old equipment. It has to be industrial grade though, so a Raspberry Pi with some wires sticking out of it doesn't work. And then finally, identification of new markets. So today we're focusing on people that cut metal, so aerospace and defense, auto parts, some medical device industries, and plastics. But if anybody has ideas on other industries where it might be a good fit, I would love to talk to you as well. That was about it.
All right, once again, wait for the microphone. I'm going to ask the first question, and I guess the thing that maybe you explained at night just didn't get it was, how are you gathering the data, quite frankly? I mean, are you partnering with people who build sensors? Are you, that kind of, I was unsure. I can see you are able to collate it, process all this information. But how are you actually gathering it, and how, if I'm an old manufacturer, how can I actually get that data?
So most of the equipment that's been built in the last 15 years has sensors in it and PLCs or programmable logic controllers in it. And we can talk to most of those through a partnership with a company called Kepware. Kepware built a product that can talk to about 100 different industrial protocols. So that's kind of how we bridge that gap. It's when you get older than 15 years, then they have to be retrofitted with something, right, to be able to gather that data.
Are you trying to partner with someone to be able to retrofit it?
Yeah, one of our customers is also an industrial automation company, and we do that work. So we do. I'm always looking for more partners, obviously because it's a product that can be sold across the United States. But yeah.
Okay. Next question, anybody?
So have you reached out to the Missouri Manufacturers Association?
Yes. Yeah.
Okay. In terms of getting a database involved. And if you haven't, come see me out.
I'll come see you.
I have some information that might be useful. So,
Okay, great.
in terms of customer acquisition.
Okay, cool. Thank you.
Not to belabor the point a bit, but could you elaborate what manual data collection looks like? I'm having sort of some trouble visualizing it after being on some of the floors that I've seen.
Yeah, so our product is mobile friendly, so you can load it up either on like an industrial tablet that is attached to a machine, or even on the controls that are on some of the tools, and it's touch friendly. So when you're reporting quantities, it's literally just you hit a button. If you have scrap, it's you hit you're just punching buttons. So we made it as easy to use as possible.
And then as far as the reporting and streaming, is that then being stored and then offloaded at a later time, or is it streamed via Wi-Fi or some other connectivity?
Yeah, typically Wi-Fi or Ethernet.
Thanks.
Yes.
Right next to here.
Oh, sorry.
This is a great way to take scientific management to its utmost. Do you have a way of then helping, honestly the point I guess is to anticipate how a firm might fit better in its broader context and its system, but is there any way to kind of scale this so that they're looking at what other people are doing and then making sure they're prepared for, because you're going to get the most efficiency out of what people already have.
Right.
But is this going to extend to help people make judgments, decisions about what resources they need, where they need to expand? Is that the whole point? And can that be integrated into the system, or is that another system entirely?
Yeah, so part of it is that. So understanding what your capacity is and kind of what your issues are, so that you can fix them in whatever way. So if that's automation, adding new equipment, adding another shift, That's definitely part of it. We're working with actually Bradley University on developing a standard set of dashboards by industry, so that we're kind of giving them best practices. This is what you should be looking at to be able to improve your business. So I don't know if that totally answers your question.
I guess if I can try to simplify it more, you're getting great at telling people how efficient they can be, but looking outward at the broader business ecology, is that something you can bring into your system?
I hadn't really thought about it, actually. It's a good idea. I hadn't really thought about it.
How well would this work with low technology manufacturing? For example, I work in a small to medium-sized chemical company, and so we'll do about $30 million in business, but chemical mixing is kind of just pouring chemicals together. And so it's very low technology with essentially custom hand-built equipment that was built some time ago.
Right.
How can this adapt to low technology, like low-level technology manufacturing?
So different companies measure different things. So you would look at, in a chemical company, you probably have mixing tanks of some kind, right? Which is probably your biggest constraint. That or people, right? People are usually elastic. You can always hire more people. But, typically the equipment is the biggest constraint. So you look at utilization on that equipment, like, are we using it as often as we could be? And if we're not, why not? So for low-tech companies, it does work. You just look at different things, right? So maybe quality is not part of it. Maybe performance isn't part of it. But you really just focus on utilization of your equipment. What's really constrained.
Actually, thinking of chemicals, it comes into scalability. So for example, when you have a 500-gallon batch, the heat distribution when you add an acid to that system is going to be different than if you try to make it in a 10,000-gallon batch. And so if you try to make it in a 10,000-gallon batch, you're going to have much more heat, and it's going to warp your chemical.
Okay.
And so it's not so much like people performance, it's kind of like just the problems of the chemical system.
So we could tell you what the temperature was when you were making that particular batch. So like if it comes out and has a problem, you would know why. So like if you're 5 or 6 degrees off because you couldn't raise the temperature high enough, right, and it produced a bad product. But our product can't really help you like size that. Say if you're going to make a $10,000 batch, 10,000-gallon batch, you need to do this versus that. That's going to like an ERP. It's not a functional formulation system.
Thank you. 1100 Central Industrial Boulevard. It's where I work. You should come and talk to my boss. Jim Epstein is a very friendly older man. He has helped me personally with my business.
Okay, cool.
I know nothing about the manufacturing world, so I'm just going to say that. You said small and medium is kind of your target audience.
Yeah.
Can you define that a little bit more? Because I feel like different vertical markets have a different, like, what is small and medium business in the manufacturing world?
Yeah, so probably 35 to 500 employees.
Okay.
15 million to, really the sweet spot would be 15 million to 250 million. We can go higher, but it depends on the business. Perfect.
Ask a question back here.
Each of these machines or devices that they're attached to probably have a maintenance program. Does this keep track and can foresee that a maintenance schedule is guaranteed?
So we don't keep track of maintenance schedules at this point. We can see, it doesn't do predictive maintenance either. Like there's a lot of discussion about having artificial intelligence and machine learning to figure out machine failure. What we do provide though is the information to a maintenance department to understand when something's happening more often than it should. So we can do statistics on how many times did the machine stop for this reason. What was the total time? What was the average time? What's the median time? And usually those maintenance departments have enough experience to be able to figure out what's going on with the machine.
You could schedule, if there's going to be a shutdown, and you could go around and do all of the machines at once instead of shutting everything down because of one.
Yeah, it's a very good point. We're got there yet. Yeah.
Okay.
All right, thank you very much.